Hello everybody, this is a video about lines of symmetry. I am your host Mr. Shirley, the Mathosaurus Rex. Now this topic might be a little bit of review for some of you, but it is an important one to go over and review just a little this year before you see it again in future years of math. Okay, so to start with the definition, a line of symmetry divides a shape into two parts that are reflections of each other. Okay, so note that they must be exact reflections, so equal in size, and such that if you were to fold them along the line of symmetry, they would overlap each other perfectly. Okay, so they can't be twisted or moved or anything like that. All right, and you'll see that as we draw some lines of symmetry on the shapes, I hope. Now, shapes can have 0, 1, or many lines of symmetry. They do not have to have just one. Okay, now I'm going to get my line tool here and hopefully we can draw some lines on these. So the semicircle shape here has one line of symmetry. The arrow shape, I hope you can see it does have a line of symmetry right up the middle there. The other two ways, if you were to try and put a line of symmetry the other diagonal direction, you can hopefully clearly see that it would not overlap. The two sides of that would not be equal. But with this particular line, each side is an exact reflection of the other. Okay, now take a moment, please pause the video and see how many lines of reflection you can get, or sorry, lines of symmetry rather, you can find for this square. Okay, I'll assume you did that. You should have been able to find 4. Okay, these are the two more obvious ones, and I apologize if my lines of symmetry are not just awesome. You've seen me write on a smartboard video, so it's probably not surprising some of my lines of symmetry will be a little off as well. So you should have 4 lines of symmetry. Okay, and the triangle over here actually has 0 lines of symmetry. Okay, very sad for this poor triangle, but no lines of symmetry. There's no way to get a line in there that would make two shapes that are reflections of each other. All right, on we go. I would like you to pause the video again and try these out. See how many lines of symmetry you could have. Now I'm looking for a number of them. You don't have to draw them. You could just write how many there are if you wish. Okay, I'll assume you did that, but you're of course welcome to just draw them like I'm about to do. The rectangle only has 2. Okay, even though you could put a diagonal line through that would split the shape in half. Okay, you could have 2 sections that are equal in area, but they would not be reflections of each other. Okay, try it and see if you don't believe me. But the 2 sides would be almost rotated from each other. They would not be a reflection. Okay, and the hexagon over here actually has 6. Okay, and one of the things you'll note, and we will talk about in future years of math, is that when you have what's called a regular shape, meaning that all the sides are equal, like the hexagon here or a square, the number of lines of symmetry will be the same as the number of the number of sides that the shape has. Okay, so a square will have 4. An equilateral triangle would have 3. Just as an example, I'm holding up the number 3 in front of the screen, but naturally you can't see that. So here's our 6 lines of symmetry. Okay, not perfectly drawn, but hopefully you get the idea. All right, now another thing that you can sometimes be asked to do with these particular, with these kinds of questions, whoops, dot down at the bottom, is to complete a pattern to make the shape a reflection across that line of symmetry. Okay, so with this particular shape, if the dotted line here is our line of symmetry, that means things should be reflections above and below. But clearly you can see that it's not. Okay, so you have to make it that way. All right, so just as an example, if this top left box here, if this shape was a reflection, that should mean this bottom box would be there. And I'm just going to sort of poorly color it in, but hopefully you'll get the idea. So that should be shaded in because each of these are kind of, there's one empty box in between them. All right, this one's right beside the line, so to make it a reflection, that should mean this one would be colored in. Okay, and then we've got this box down at the bottom, which would need a similar box over there to have a reflection. Okay, and now the shape is reflected. Okay, we've got 3 blue boxes on top and 3 blue boxes on the bottom that are reflections from one another across that line of symmetry. Okay, now one thing I would like you to note as you're doing some of the work for this, I would like you to be trying generally to find the minimum amount you would have to color in to make your shape a reflection across that line of symmetry. Okay, if you're looking for a loophole in this kind of question, which I don't want to see, you could just color in every box. Because clearly all 8 boxes colored in would be a reflection of all 8 boxes colored in on the bottom. Okay, but that's really not helping you understand reflection better. Okay, that's an easy loophole in the question. All right, so try and get the minimum number of boxes that you would need in order to make it a reflection. All right, on we go. I would like you to take a moment and see if you can manage to do this one. And this has 2 lines of reflection, or sorry, 2 lines of symmetry. I keep calling them lines of reflection. It's not necessarily wrong, it's just not the best term for it. So lines of symmetry, so there's 2 of them. So pause for a moment and see if you can figure out how you would do the pattern so both of them would work. Okay, I'll assume you tried that. Now the key with these kinds of questions is to do 1 line of symmetry at a time. Okay, so I'm going to start with the horizontal line. So ignore the vertical one just for now. Pretend it's not there just for now. So if we wanted to make this shape, similar to the last slide, a reflection across that line of symmetry, okay, we've got these 2 boxes right beside it, so we would need to color in these 2 boxes so that top and bottom are a reflection across that line. Okay, same with this box here. Because it's the bottom right, we would need to color in the top right so that it's reflected. Again, we're doing this one first. I'm just going to put kind of a number 1 there. We're doing this one first. Okay, so now the shape is a reflection in that horizontal line. Okay, so that horizontal line is a line of symmetry. Now we need to do the vertical line. Okay, now we've got 2 boxes here, so pretend the first line doesn't exist anymore. Just ignore that one. Okay, so we're doing this vertical line now. So because we've got these 2 boxes here, we need to have the same 2 boxes filled in on the other side of the line. Okay, so if you were to flip this over, these are the 2 boxes that would be filled in. Okay, so we've got those 2, but we've also got these 2 boxes now filled in from our first step. So we've got to do something similar and fill in the 2 boxes on this side. Okay, and then we're still missing a little bit because of this line of reflection. So we've got that top right and bottom right box, but because we're reflecting it along that vertical axis rather, up and down, we need to color in the top left and the bottom left so that they will be reflections of the top right and bottom right. Okay, and now this shape, no matter which of those 2 lines that you are using, will be reflections horizontally and reflections vertically. Okay, so I hope that makes sense. If you do have questions, please feel free to ask in all the regular ways, and we will go over a few examples of these during our meetings this week. Thank you very much for watching, and have a super day.